Hello, this is problem 654 from the textbook. In this case, we are given the flow field composed of the uniform stream incoming from the left that is being partially passing over the flat plate and partially being sucked through the linear slot at the wall. And the inner velocity is 2 meters per second. And the sink strength, the suction rate here is 0.3 meters squares per second. What it says here in the text is 0.3 meter cubes per second per meter length of the slit, so that boils down on a unit segment of 0.3 meters squares per second. So assuming that this is incompressible inviscid fluid, we are asked to determine the position of the stagnation point A and the incoming streamline that basically divides the region into the fluid that is being sucked through the slit and the fluid that flows over and continues. So here we have stream function as a combination of uniform flow and the sink. Which is, if you consult your elementary flows, for uniform flow in polar coordinates, we have UR sine theta minus m, that's the flow rate, over 2 pi theta. So from this we can readily obtain velocity components u and v, or rather radial and angular velocity. So ur is 1 over r delta theta per delta phi, delta psi per delta theta, which is u cosine theta minus m over 2pr, and then u theta is minus delta psi per delta r, which is the second term does not depend on r, so it's just the first term, which is minus u sine theta. So now that we have the velocity component, we want to find the stagnation point. So along the wall, we know that ur is going to be u theta is 0, because if you look at the fact that the wall passes through the coordinate origin, then at any point u theta is perpendicular component. So we know that u theta is 0, and we're looking for the point where ur itself is 0, because when you look at point A, this is the point where horizontal component of velocity is also going to be 0. So find r for ur equals 0. In other words, we're solving the equation for velocity ur, u cosine theta minus m over 2 pi r equals 0. And of course that will be the point where u cosine theta is equal to this. But all along the wall theta is 0, so we have cosine theta which is 1. And we have essentially r of a equals m over 2 pi u.